Okay, after going kind of through what science is not, the textbook terms to what science is. And you already know this. Again, you've taken grade 3 science, I'm assuming. You might not have all the steps kind of clearly laid out, but I'm sure you've heard of the scientific method and generally have a picture of what the idea is. So this will be just really simple review and I'll breeze through it. So one thing to keep in mind, so the textbook gives like a 5-step scientific method. I've seen 7 steps, I've seen 3. It doesn't really matter the number. You get a general picture of what's involved in the scientific method though. And go through it. So the first thing that you'll come up with is a problem or a question. That dates right back to Aristotle, who said knowledge begins with wonder. So it's a questioning attitude about the universe. Why is this like that? Why is that like that? Yeah, it's a questioning attitude, a problem or a question. It could be anything regarding states of affairs or matters of fact. Can be anything. Why is the sky blue? How come milk doesn't come out of cows' noses when they laugh? Can be anything. Yeah, you can ask those questions, and hopefully science can help you answer them. Right. That's the first thing you come up with. Second thing, obviously, you pose a hypothesis, a possible explanation that seems reasonable for what the phenomenon is. Why do bodies move in a certain way? Well, gravity or something of the sort, right? You get an idea. You come up with a hypothesis to be able to explain that particular thing. Third step, obviously, you devise a test for the hypothesis. Now, that's what we're going to focus on. We're going to focus on 2 types of tests that are discussed by the textbook. So pay attention to those particular sections, and that's where the assignment is going to be based on as well, too. So when I get down to that, pay attention. But yeah, you devise a test for the hypothesis. An experiment, that's where the experimental aspect of science comes into it. Third thing, the fourth and fifth are kind of like, well, duh. But the fourth step is you perform the test. I would think that would be a given that you perform the test. And then the fifth one also seems kind of like a no-brainer to me. Obviously, you're going to kind of formulate an opinion regarding the hypothesis based on the results of the test. You're either going to accept or reject the hypothesis based on the results. That's kind of it. Now, the textbook gives 2 methods of testing that kind of go along with it. They're fairly comprehensive. I'm not sure if the textbook intends them to be kind of comprehensive of all sorts of tests that you can do, but it seems pretty good to me. Anyways, the first one that's discussed by the textbook is what's called double-blind testing. Those are the ones you're familiar with from stats and from psychology and from medical kind of experiments as well, double-blind testing. That's where you kind of set up an experimental group and you set up a control group to kind of control for various variables that might be involved in an application of something or a test or an experiment, right? But I'll run you through the process, the kind of process of doing that. And the example the textbook gives is pretty good of that. So let's say you work in a palliative care institute. You're a nurse there or something of the sort. Well, let's say you're a doctor, because that puts you more on the research side of things, right? And you keep hearing from people. You hear from nurses, you hear from family members, you hear from patients themselves in this palliative care institute for cancer patients that, look, I started taking vitamin C and I started feeling a lot better. And in fact, the nurses are telling you those who take high doses of vitamin C, even though they've been diagnosed with kind of an incurable form of cancer, they live a heck of a lot longer than those who do not. So that kind of, you can see the problem there suggests itself. You start asking yourself, well, could vitamin C be prolonging these people's lives? It's not curing them, but could it be prolonging them? That'd be your question. What would your hypothesis be? Well, your hypothesis would be suggested by the question itself. We can say, okay, well, my hypothesis, I'll say based on the anecdotal evidence. Sure, yeah, okay. Vitamin C is in fact doing that. It's prolonging the lives. How do you actually test that in an efficient way to see if that's actually the case, right? Because, of course, that anecdotal evidence just could be wishful thinking or bias on the part of those people who are suggesting it, right? So the first thing that you do in a double-blind testing kind of method is you set up what's called an experimental group. With the experimental group, you actually apply. You apply the hypothesis on that group. So in this instance, you would want to pick a group of cancer patients who've been diagnosed with a terminal form of cancer. And you'd want to kind of rule out different variables. So you'd want a good kind of representative amount of people where age isn't going to be that much of a factor, or where other health concerns aren't going to be that much of a factor as well, like to represent kind of the population that would have that as closely as you possibly can. So you'd want to do that. And then what would you do? Well, obviously, you would just give them vitamin C. You give them vitamin C and you track how long they live. That's your experimental group. And if they seem to live a lot longer, obviously, that's the case. Now, what you want to do, obviously, is you also need to set up what's called a control group. The control group, because you might track their age for a certain amount of time. It might seem a bit longer, but that could be other effects as well going on. So you want to set up a control group, because in the event that you actually do see that these people are taking vitamin C are living a lot longer than others, that could be what's called the placebo effect. So you want to set up a control group to make sure that's not the placebo effect that you're seeing in your experiment. So what do you do with your control group? Well, you give them a placebo. You give them a sugar pill. You tell them it's vitamin C. Here, you're going to take this. We're checking to see if it's going to prolong your life. And you give them that little sugar cube, that placebo. They take it. And then what do? Well, obviously you have you track how long these people live. If the experimental group, the people in that experimental group tend to live longer than the people who are in the control group, then that's evidence that that vitamin C actually is prolonging their lives. If not, if it's equal, then in fact, of course, that would be evidence against the hypothesis. And obviously, if the control group's living a lot longer than the experimental group, then that is reason to think that the vitamin C might actually be harming them. So, that's kind of how it works. Now, keep in mind the reason why it's double blind. So not only between the experimental and the control group do they not know who's actually getting it. Everyone thinks that they're getting vitamin C, so they're sort of blind to that aspect of it. But also the people who are administering the actual experiment themselves are not going to know which group is which. Because, of course, their biases could come into play in recording and interpreting the data as well. So that's why it's double blind. But that's kind of it. You're on it, you track that, and, of course, you either accept or reject the hypothesis on the basis of that. So that's kind of how double blind testing works. Now, the other method is kind of much easier to understand, although it doesn't seem as scientific as the other one for some reason. I don't know why, but at least on the surface of things. It's what's called verification or prediction forms of testing. Verification or prediction forms. So the idea is, look, if this particular theory is true, then what are the consequences from that we can actually observe? So some theories might not be testable in that way. In fact, some theories might not be testable at all. So that God caused the universe, I don't know what evidence would be able to see that that's the case. There's no way to really test that particular hypothesis, that God was involved in the creation of the universe, for instance, or something of the sort, right? But with other hypotheses that are in fact is, right? So if this is true, then what follows from it? What follows from it? And two kind of examples that the textbook gives kind of highlight this perfectly. So actually, I can't remember if the textbook talks about the Manhattan Project, but it's the one that I think of whenever I think of verificationism. So I'm assuming you guys know what the Manhattan Project is. If you don't, it was American efforts during World War II to create the first atomic bomb. It was codenamed the Manhattan Project, and they, of course, succeeded in creating just that, a big giant cracker. It'll kill a lot of people, right? So it was based on Einstein's theories, obviously, right? So, and the idea was, look, if Einstein's true, then we ought to be able to build this big bomb. We ought to be able to do it, right? So if Einstein's theory is true, we can predict that this should be the case. That's kind of how it works. So the actual experiment of building the bomb was testing Einstein's theory itself, because, of course, Einstein's theories in the initial decades where he kind of formulated were hotly debated. A lot of people debated that he was completely wrong. Some said he's got certain aspects of things wrong or off. And that went on during the Manhattan Project as well. So yeah, during the Manhattan Project, and it's actually kind of scary when you think about it, the scientists themselves, apparently, legend has it, disagreed about what would actually happen if they split the atom. They actually disagreed. So some people thought, look, nothing will happen at all. Einstein's just wrong. A lot of people thought, well, no, Einstein's correct, and this bomb will detonate in the way that we think it should. And still another group thought, well, Einstein's kind of right, but here's what's going to happen. It will split the atom. That'll cause a chain reaction, which will destroy the entire planet. So you had various debates about what was going on. But what happened? They built the bomb. It went off as should, verifying Einstein's theory is correct. The other example that the textbook uses, and it's actually a really good one, is the theory of evolution. So the theory of natural selection come up with by Charles Darwin. Obviously, it was hotly debated when it kind of was first proposed, right? And what happened? Well, there was a considerable amount of verifying that particular theory that had to take place before there was no debating anymore whether or not Darwin was correct. The theory of evolution. So what ought we to see? You can simply ask yourself, look, if Darwin is correct, what ought we be able to find? And there were two things that kind of people thought of. First of all, the fossil record. So we should be able to look at the fossil record. We should be able to find fossils somewhere that will show gradual development of different species from kind of a main species, or branching out of species in some ways. The slow development of species over time. That's one thing that we should be able to see. And of course, they went out, and what did they find? The fossil record was gradually filled in over the decades. All the missing links were kind of put together, and we can see, that's what we find. We find development over time of species. The second thing is, look, if Darwin's correct, then we actually should be able to see natural selection taking place now. So it should be a kind of a mechanism operative in nature now. And of course, what happened? Well, they found it. They found it in flu viruses. Flu viruses, you got to get a different shot every year. Why? Because the thing keeps adapting. The thing keeps adapting, right? That's kind of another example of how that works. So, but again, with verification or prediction forms, you simply ask yourself, okay, look, if this is the case, then what ought we be able to see as well? And that's kind of how those work.